Hello, welcome to today's class. Here we have this challenge before us here. How do we evaluate this without the use of the calculator? Okay, so I'm going to take you on a step-by-step ride on how to solve this challenge here now. Okay, so let's take our solution. Take solution straight. Now the question is bracket open the square root of 15 plus the square root of 3 close bracket all over the square root of 12. There's a simple method I apply in solving this kind of challenge when it is without the use of the calculator. So the first thing I'm going to do here is to say like using P, okay? So let P be equal to the whole of this expression, which is bracket open the square root of our 15, then plus the square root of 3 all over the square root of our 12, all raised to the power of what? 18. Now, I want to eliminate this power 18 here. Okay, so we take the integer root of both sides of this equation. And so this is going to give us our p to the power of 1 all over 18 is equal to bracket our square root of our 18, sorry, square root of 15 plus the square root of r3 all over our square root of 12 all raised to the power of our 18 further raised to the power of 1 all over 18. So if we apply the rule of indices, it says that if you have your, let's take our a to the power of our m, or in bracket raised to our n, this is equal to our a to the power of our m n, then we can use this to multiply this. And if we do that, this will leave the system. So we're now having our p to the power of 1 all over 18 is equal to our square root of our 15 plus the square root of 3 all over square root of our 12. Now I did this just to avoid writing this over and over again. Okay, good. So the next thing we do is to simplify this expression. Look at the smallest radical here. We have the square root of 3 here. So we can bring out square root of 3 from here. We can equally bring out square root of 3 from here also. Okay, so how do we do that? Then this is going to give us here 15 can be expressed as our 3 times 5. So this is going to give us 3 times our 5, then plus root 3 remains root 3 all over. Then our 12 can also be expressed as 4 times 3. So we have here 4 times our 3. And according to the law of surd, we can separate this to give us root 3 times root 5. And here, root 4 times root 3. And 4 is a perfect square, and so that will give us 2. So rewriting this is going to give us, let's continue here. So this automatically is going to give us our root 3 times our root 5, then plus our root 3 all over our 2 root 3. You now discover that root 3 is common to here, common to here. So we can factor out root 3 from the numerator. If we do that, this is going to give us root 3 then into our root 5, then plus our 1 close bracket all over 2 into our root 3. This is multiplication. And so this leaves the system. And so we're now having our p to the power of 1 all over 18 is equal to our root. Now look at this root 5 plus 1, because this is addition. So we can start by saying our 1 plus our root 5 here all over 2. And here we have to look for p, because look at the expression. What I did, I said let p be equal to this. So we can rewrite 18. How do we simplify 18 down? We can break down 18 in this format. So if we have our 18 here, what is the simplest number that can go into 18 is 2. 2 into 18 will give us 9. Again, what can go is 3. So 3 here will give us 3. And again, what can go again? 3. 3 here will give us 1. So 18 can be written as our 2 times 3 times 3. So if that is the case, we want to, first of all, handle this here now. In other words, want to raise both power, or yes, both power here and here to 2, which is the first 2 we're going to have here, right? Good. So we can decide to rewrite this expression here. So this is going to give us our P1 all over 18 all raised to the power of 2. Then we do same thing here. And here we can rewrite this as our 1 all over 2 plus root 5 all over 2, all raised to the power of 2. So what happened? This here 1 here will go to give us 9. Now look at this. We're going to make use of the binomial expansion method, okay, whereby we're going to use the Pascal diagram or triangle to get the coefficient. And we're going to make use of the second power and the third power according to this expression we have here. So from our Pascal triangle, we know that to the power of 0, the coefficient is going to give us 1, and to the power of 1, we're going to have 1 here and 1 here. Then to the power of 2, we're going to have 1. Add these two together to give us 2 here and then 1 here. And to the power of 3, we're going to have here 1. The 2 plus 1 will give us 3. Then 2 plus 1 here will still give us 3 here. That we have here. So we'll be dealing with this expression here, this coefficient here, and also this coefficient here also. Okay, so we are going to expand to that of power of 2 here. Okay, so if we are doing that, what will happen? We're going to have here our P raised to the power of 1 all over 9 that is left out here. This is equal to the first coefficient is going to give us 1, and so this is going to give us 1 all over 2. Okay, so all raised to the power of what? 2. And this second term, the power is going to be 0. So since it's 0, that will give us 1. And so we go to the second term. Now, the second term here, the coefficient is 2. So we're going to have here 2 into, let's put this into a square bracket. This power here will reduce to 1, so we're going to have 1 all over 2 times this, the power will increase to 1. So we're going to have here root 5 all over 2, or in square bracket, raised to power 1. Okay, so let's still leave this here. Then plus this next coefficient is 1, and so this, it has reduced to 1, and here is going to leave the system. Meanwhile, this will now increase to 2. So we have the square root of 5 all over 2, all raised to the power of 2. Easy, right? So now let's simplify and see what this gives us. So this is going to give us here we're going to have 1 all over 4 there, plus here we're going to have 2 times 2, 4. Then if we use this to multiply this can go with one of these. So we are left with root 5 all over our 2 here. Then plus, if we use this to open up this will go with this, and this will equally affect this. So we are having 5 all over 4. We can add this and this together. So if we go ahead to do that, so this is going to give us here our 1 plus 5, because the denominator are the same. So 1 plus 5 is going to give us 6 all over here. We have 4 there, plus our root 5 all over 2. Okay, so 2 here will give us 3, 2 here will give us 2, right? So we have our P to the power of 1 all over 9. So let's continue here and see what this gives us in turn. Then we're going to have here our P to the power of 1 all over 9. This is equal to, so we have 3 all over 2, there, plus our root 5 all over 2. So again, we simplify this. We are through with this power now. So we want to take this next power, right? So we raise this to power 3. So this is going to give us here, raise this to power of 3. We equally raise this to the power of 3. So this will give us here 3. So we now have p to the power of 1 all over 3 is equal to, so we're going to use the binomial expansion again. We are going to consider this power here now. So if we consider this, so this is going to give us, the first term is going to give us 3 all over 2, all raised to the power of 3, then plus the second one, the coefficient is 3. So we're going to take here our 3 into a square bracket. The first term here, which is our 3 all over 2, all raised to the power of 2, then times, this will come into the system, which is root 5 all over 2, right? Then close bracket, then plus, the next one we're going to have 3 as the coefficient, which is this, then this has decreased to 2, here it will now decrease further to 1, which is 3 all over 2, here, 3 all over 2, then times, this will increase up here, so we have here root 5 all over 2, all raised to the power of 2, then close our bracket. I will get the something here, then plus the next coefficient is 1, meanwhile this will be raised to 0, which is 1, and this will be increased to 3. So we have this square root of 5 all over 2, all raised to the power of 3. Easy. All right. So from here, we proceed again. Now, 3 to the power of 3 will give us 27 all over 8, then plus. So we come to this side, yeah, 2 will affect 3 and also affect our 2 here. And so this is going to give us 3 times 9, which is 27. So we're going to have here 27 root 5, right? Then all over, here we have 4 times 2, which is 8, then plus, then we come to this other side. We know these 2 here, we cancel out these 2 here, and 2 will also affect this, right? So this is going to give us our 3 times 3, that is 9. 9 times 5, that will give us 45. So we have 45 all over. Here we're going to have 4 times 2, which is 8. Then plus this other side of it, this is going to give us 5 root 5. So let's manage this space here, 5 root 5 all over. Here we're going to give us 8. So let's bring that our term here. So have our p to the power of 1 all over 3 will now be equal to, we can add this and this together, add this and this together, right? Good. So this is going to give us 27 plus our 45, that will give us 72. So we have 72 all over 8, then plus, then 27 root 5 plus 5 root 5, that will give us 32 root 5. So we have 32 root 5 all over 8. The denominator can divide the numerator. So 8 here, 1, 8 here will give us 9, 8 here, 1, 8 here will give us 4. So we're going to have our p to the power of 1 all over 3 is equal to, here we have 9 plus 4 root 5. Wow. So this is the last lap. So we have to eliminate this, which is this last 3 here. So doing that, we raise this to the power of our 3. We equally raise this to the power of our 3. So this leaves, right? So we're going to have our p standing alone. So p will now be equal to, we're going to expand using this again, all right? So let's continue on this side for a better space. So expanding that to the power of 3, so we're going to have our p now standing alone. Will now be the first coefficient is 1. So this will now be to the power of 3, then plus the second coefficient is 3. So we're going to have here our 3 into our 9 to the power of 2, then times the second term, which is this here, is going to give us 4 root our 5, right? Then let's put this in square bracket, then plus the next term, the coefficient is 3, then into our square bracket, here 9 will be 9 to the power of 2, then times our 4 root 5 to the power of 2 this time around, right? Is it 2? No, this will reduce to 1, sorry. So this will reduce to the power of 1, which is same thing as 9, right? Same thing as 9. Then this will give us 2, or in square bracket, then plus the last coefficient is 1, which is going to take only 4 root 5, all raised to the power of 3. Wow, so this is the expansion, right? So let's go ahead and find the value of this. So 9 to the power of 3 will give us 9 times 9 times 9, and 9 times 9 will give us 81. 81 times 9 will give us 729. So we have 729 there, plus, here we're going to have 81, right? So 81 times 3 times 4, and that will give us 972, right? Then root 5, okay? Then plus, then when we come to this is going to give us 16, right? And these two, we cancel this radical here. So we're going to have 16 times 5 times 9 times 3. And that will give us 2,160. So we have 2,160. Then plus this is going to give us 4 times 4 times 4 into 3 places. And this into this will give us 5 root. Okay, so we're going to have 4 into 3 places times 5 times root 5. And if you multiply that out, that will give you 320 root 5. Okay, so we can add this and this together. Then add this and this together. Easy. So let's go ahead and add up. So if we add up this, so let's start with this. So this will give us here 9. Then 2 plus 6 will give us 8. Then 1 plus 2, sorry, 1 plus 7 will give us 8. Then 2 plus 0 will give us 2. Then plus, we come to this automatically will give us root 5, right? So 2 plus 0 will give us 2. Then 7 plus 2 will give us 9. Then 3 plus 9 will give us 12. So we have here 12. Yeah, all right. So in all, we cannot say therefore, because here we have our P is equals to this. So expanding this to this power will give us this. So we cannot conclusively say that therefore the square root of 15 plus the square root of 3 close bracket all over the square root of 12 all raised to the power of 18 is equal to our 2889 there plus our 1292 root 5. Right. So this brings us to the end of this math class. So thank you for being there. But again, if you learned something from this video tutorial, give the video a thumbs up. Do not forget to visit our channel for more videos. Stay tuned. See you in our next class. Bye for now.